Lesson: Integrating AI models into existing systems via scripting. Integrating AI models into existing systems through scripting is a critical skill for professionals seeking to enhance system capabilities and drive innovation. The process involves leveraging programming scripts to embed AI functionalities into current infrastructures, ensuring seamless operation and boosting system intelligence. This lesson delves into actionable insights, practical tools, frameworks, and step-by-step applications, offering professionals direct implementation guidance. By utilizing scripting, AI models can be integrated without extensive overhauls, allowing for cost-effective and efficient enhancements. The foundation of integrating AI models into existing systems via scripting lies in understanding the architecture of both the AI models and the systems they will inhabit. AI models, such as those developed via machine learning frameworks like TensorFlow or PyTorch, are designed to perform specific tasks based on trained algorithms. These models can be incorporated into systems using scripting languages like Python, JavaScript, or shell scripting, which facilitate the interaction between AI models and the system's operational components. A practical starting point for integration involves identifying the system's requirements and the AI model's capabilities. This assessment allows professionals to determine the feasibility and scope of integration. For instance, a retail company aiming to implement an AI-based recommendation system into its e-commerce platform would need to ensure that the model's prediction algorithms align with the platform's data structure and user interface. By utilizing a scripting language like Python, the company can write scripts that fetch user data, pass it to the AI model, and then display the model's recommendations directly on the website. One of the most effective tools for this type of integration is the use of application programming interfaces, which serve as intermediaries between the AI model and the system. APIs allow for smooth communication and data exchange, enabling the AI model to access necessary inputs and return outputs without disrupting the system's functionality. For instance, cloud-based AI services like Google Cloud AI or Amazon Web Services AI provide APIs that can be easily scripted into applications, allowing businesses to leverage powerful AI capabilities without developing models from scratch. The scripting process often begins with data preparation and pre-processing, which involves cleansing and organizing data to ensure compatibility with the AI model. This step is crucial, as AI models require high-quality data to generate accurate predictions. Scripting languages like Python offer libraries such as Pandas and NumPy, which streamline data manipulation and preparation. Once the data is prepared, scripts can be written to feed this data into the AI model, often using libraries like TensorFlow or PyTorch to facilitate the interaction. A significant challenge in AI integration is managing the computational resources required by AI models. Many models, especially deep learning ones, demand high processing power and memory. Scripting can be utilized to optimize resource allocation, ensuring that the system remains efficient even as it processes complex AI tasks. For example, scripts can be written to allocate tasks across multiple processors or to utilize cloud computing resources, which can provide the necessary computational capacity without overburdening local systems. In practice, an AI model integration might involve developing a script that automates the model's deployment within a system. This script can include steps for loading the model, pre-processing input data, executing the model, and handling the output. For instance, a healthcare application might integrate an AI model that predicts patient outcomes based on clinical data. The script would automate data collection from electronic health records, pre-process the data to match the model's input requirements, run the model to generate predictions, and then store the predictions in the system's database for clinicians to review. A real-world case study illustrating successful AI integration is the implementation of AI-powered chatbots in customer service systems. Companies like H&M and Sephora have integrated chatbots using scripting to enhance customer interaction and support. These chatbots are powered by natural language processing models, which interpret and respond to customer inquiries. The integration process involves scripting APIs that connect the chatbot to the company's database, allowing it to retrieve and update customer information as needed. Another example is the use of AI models in predictive maintenance within manufacturing systems. By scripting AI models to analyze sensor data, companies can predict equipment failures before they occur, reducing downtime and maintenance costs. This requires writing scripts that continuously monitor sensor data, pre-process it, and input it into the AI model to generate maintenance alerts. The efficiency of such systems has been demonstrated in industries like automotive manufacturing, where predictive maintenance has led to significant cost savings and improved production efficiency. To ensure the successful integration of AI models into existing systems, professionals must also address security and ethical considerations. Scripting can be used to implement security measures, such as data encryption and access controls, to protect sensitive information processed by AI models. Additionally, professionals should be aware of the ethical implications of AI integration, ensuring that models are transparent and unbiased. Scripts can be written to log model decisions and provide explanations for predictions, enhancing transparency and accountability. In conclusion, integrating AI models into existing systems via scripting is a powerful approach that offers significant benefits in terms of system intelligence and efficiency. By leveraging scripting languages and tools, professionals can seamlessly embed AI functionalities into current infrastructures, addressing real-world challenges and driving innovation. The use of APIs, data preprocessing libraries, and cloud computing resources are just a few examples of how scripting facilitates AI integration. As AI continues to evolve, the ability to integrate models into systems will become increasingly important, requiring professionals to stay informed about the latest tools and techniques in this dynamic field.